Hello, this is Firdaus Ahmed. I'm a graduate student at Georgia Tech OMS CS program. This fair tutorial is a part of CS 6440 Intro to Health Informatics assignment. In this tutorial, I'll go over detail about FHIR and how it can be used by developers. There are some basic requirements to understand this course. The tutorial is intended for people with basic programming knowledge in Java and some familiarity with Java IDEs. So, what is FHIR? FHIR stands for Fast Healthcare Interoperability Resources. It was developed by Health Level 7 International, which is also known as HL7. It is an interoperability specification for the exchange of healthcare information electronically. The aim of FHIR is to address the growing digitization of the healthcare industry and the need of patients' records to be readily available, discoverable, and understandable. Essentially, the goal of FHIR is to standardize the exchange of healthcare information, enabling healthcare providers and administrators to easily share patients' information even when they are using different software systems. With FHIR, each resource is associated with a unique identifier. Much like URLs make it easy to find a specific web page regardless of the device or browser you're using. So FHIR makes it is possible to access the right information from any application or device. By creating standard URLs for packets of information, FHIR eliminates the needs of exchange individual documents or data back and forth between systems, while ensuring that the disseparate application can be point to the right information and same version of that information simultaneously. Say for an example, if a patient moves from one state to another state, he might have to change his primary care doctor, and the primary care doctor might want to know his previous medical record. With FHIR, it would be very easy to add that information to the patient's personal healthcare record so that he can share the information that he wants to share with the current doctor. Or if the patient allows the current doctor to get the resource from the previous doctor, it would be very easy if both of the EMR system follows the FHIR specification, and that way it can be done very easily. So how FHIR works? FHIR was designed specifically for the internet. It is built on the concept of resource, any content that is exchangeable, which are used as building blocks that can be incorporated in existing system resource. A resource must have few common definition, uh, a common set of metadata, which should be human readable, and resources are based on either XML, JSON, HTTP, and OAuth. The aim is to create a framework that is used to extend and adapt a resource and can be interpreted by any system, no matter how it was developed. So it can be used in any application that you want to store your health record system. For an example, Apple uses their health record system, which is FAIR standard specified, meaning that if you store anything in the Apple's application, your doctor's EMR, if they follows the same standard, that can be can get all the information from the Apple's health kit. There are some challenges to use FHIR still, because FHIR is still very young to evolve, so it will evolve eventually. So while it is very good in theory, FHIR isn't yet ready for prime time. It is also not without its challenges. So FHIR shares many of the same challenges as HL7 integration has. So there are different versions of FHIR that implement differently. They follows different APIs, and the EHR versions needs to also follow those specific versions to comply with those FHIR versions. So this is If this is inconsistent with the EMR systems and the fire side of it, then it will be a challenging situation for the. And now I will walk through the basic CRUD operation. CRUD is a simple term that was abbreviated because it's a common feature in many applications, and it is easier to say CRUD. It describes 4 basic operations you can perform on data or a resource. In our case, the patient. So it has 4 operations, which is create, read, update, and delete. These are 4 main actions that you will use to interact with file resource within a file server. When you have a URL and you point your browser to it by the address line, you're sending an HTTP request. Each HTTP request contains information that the server can use to know which HTTP response to send back to the client that issued the request. Understanding these 4 operations is essential to working with any RESTful services, which a file server is an implementation of. REST stands for representational state transfer, and RESTful just means that a system that conforms the constraint of REST. So here we are in the Fire overview for the developers, which states Fire is designated to enable information exchange to support provision of healthcare in a variety of settings. This specification builds or adopt modern, widely used RESTful practices enable provisions of integrated healthcare across the wide range of terms and organizations. So the frameworks, it's based on the resource. So the resource is the key here. All the resources have the following features in common. So it will have a URL that identifies the resources, a common metadata, a human readable XHTML summary, a set of defined data elements, and extensibility of framework to support the variation in healthcare. So resource instances can be represented either in XML, JSON, or RDF, but mostly nowadays we like to use JSON. This is an example of an instance. So this is a resource for a patient where we see at the beginning the resource type is a patient and it has a unique ID. So with this ID I can identify what the patient's is, and there should be the patient's name, family name, given name, if there's a suffix, gender, date of birth, active or inactive, and there are some other identifier labels, and then status, generated, last updated, and the version of this instance. So each instance of a resource consists of few things, which are resource type, ID, meta, text, extension, and data. And the interaction, as we just discussed, there are CRUD operations. So it can create a resource, and it can read a resource, it can update a resource, it can delete a resource, and it can search a resource, and there are other operations too, which we'll go over later on. So I'll go with the creating a resource. How do you create a resource? So creating resource means if you have a resource like a REST server or something, and you want to create, meaning that you want to insert a new record to a database in the back behind. So to create a resource, you send a post request to the resource type through the respective endpoint. So the endpoint looks similar to this example, and then I have to define the path and the resource type. Submit a new patient to the server and ask to store the patient with its ID and its own choice. So I need here the patient, the authorization, and the content type. And then I will get a response from the server. If the resource got created successfully, then I'll get a response from server saying that 201 created, meaning that the server was successfully created that resource. If it was unsuccessful to insert or create the new record, it will actually give me 422 unpresentable entity. So now let's go to the read request. Reading a request is basically done by doing a HTTP GET request, and To do that, we will actually have to send the patient ID or patient name. If we send patient name, there can be multiple lists that we'll receive, because multiple patient can have same name. So if we want to identify a single patient, we need to pass patient ID to find that patient. If the read call is successful, then I'll get an HTTP 200 OK response, meaning the server recognizes my call and then it's sending me the response for that. So search is very similar to read. It actually uses the same operation, the get operation. So with search, I can actually specify if I have a specification where I want to know not only patient's name but also maybe his gender. I want to search. I want to see which patient has the same birth date or which patient is male or female, and then I will do a search with that criteria. This is an example of the resource that I might get using a search call. So in a search, I will get the result as a bundle. So from that bundle, I can manipulate the data to read my specific need. Now comes to the update request. So if we need to update a patient information, then we can use the put call. So in this case, we have to identify the patient ID, and with that we can actually update the patient record, any of the patient record. And this one should have last updated and the version ID. So every time I update an instance, the version ID should change so that I can track it. It is same as get request. If it is successful, then we'll get 200 OK. This is an example of the base resource content. And there is also another method called delete. I will show in the demonstration that how to perform that. So if I want to remove the record of a patient, I can do that by doing a delete operation. So now I'll go to the HappyFair, which is a test server that is available for the developers to use and to learn how the fair data can be manipulated and how the CRUD operation can be easily used. So I will start with the HappyFair simple. So I'll go to the server home first, and I'll do a conformance statement, which will actually just call the metadata. And if you see that it actually sent me a response of 200 OK, meaning that the call was fine. If you see, I'm using the base as a base source. I'm using base DSTU3, so it's a metadata, and then I want to see it pretty so that it's more readable to me. So this is the updated response that I got from the server. So now that I know the server is fine, I can go to the resources and see how can I read them and how can I update them. So the resources have an operation called CRUD operation, which you can read, which can delete, which can create, which can update, and also some other functions like validate and then history. So for this, if I search with a name, I will search for a name, and then that matches, I'll search for someone named Scott and then search. So my search actually returned, and as we discussed before, there is a URL which is HappyFair.org based URL, and then patient, and then mother's maiden name is Scott. So in this way, I didn't get any response. So there's no patient whose mother's maiden name is Scott. So I'll go back and then I'll try to change it again to some reasonable name. So let's try with this one. So in this time I was successful. So the patient name is this time is Scott, and I got a 200 HTTP 200 OK message, and then I got a bundle contains 20 entries. So each of these entries are patient records. So if you look at the records, these are patient IDs, and this is the history. So I can also see the IDs and patient history. So I can see the patient, all the patient with whose name is Scott. And then if I want to read a specific patient, I can go to the read, which will call actually the patient ID and the history, and I should be able to see the patient details. So it's a resource type is patient, ID is this, and the family name is Scott. So this is for the patient resource. Now we can also look at the other observation resource too. So if I search with observation record, it will actually pull up 20 bundle of entries for observation. So for observation, I can go to one of the read just to show you an example. So I did a get call with all the observations. So I'll do some filtering here. So I am doing observation CF 1540780813534, and I want to see what is in there. So in this observation, this is the observation ID, and this is the version ID, and then when it was last updated, and then after that the status is final. The coding, it's a Lonian or code. The code is this systolic blood pressure, and there's a patient's reference, which is actually the patient's ID, so that we can identify the patient reference. So it has a value, quantity value is 110 mmHg. Let's look at another patient. So if I look at this is the observation, this is the observation ID, and it has a patient ID with the patient. So if I go to look for an observation, if I have to identify the patient of the observation, I can actually do it by looking at the reference of the patient, and unit is this is the code respiratory rate. The value is 29 respiratory per minute. So it says that. So this is a good example. I can go to the medication statement also, and if I do a search, I will see the medication for a patient. So if I go to this is the medication statement. This is the resource type, and this is the resource ID. It has a version ID and the last updated date. So it also has a patient with the reference. So this medication statement is for this particular patient. The patient has a like a medication for naproxen 500 EC tablet, and which is he's supposed to take it one tablet daily. And so he's one of his medication statement. I can check another medication statements, and then it comes like it has this issue or what similar things. This is 2 puff twice daily. So using this happy test server, I can actually test how to manipulate data, how to create patient data, how to create observation, how can I search for a specific observation or bundle of observation. So it is very helpful for the developer to play with it and learn how this works. So next we will go to create a RESTful server. So we'll see how in the Happy Fire how to create a RESTful server. So Happy provides a built-in mechanism for adding fair RESTful server capabilities to your application. The Happy RESTful server is a serverless base, so it should be easy to deploy to any of many compliant containers that exist. Setup is mostly done using simple annotation, which means it should be possible to create a Happy Fire compliant server quickly and easily. So let's go through it and see how can we create a RESTful server using Happy Fire. So first we will define the resource provider. The first step of creating the RESTful server is to define one or more resource provider. A resource provider is a class which is able to supply exactly one type of resource to be served up. For example, if you wish to allow your server to serve up a patient observation location resource, you will need 3 resource provider. A resource provider class must be implemented iResource Provider interface and will contain one or more method which has been annotated with a special annotation indicating which RESTful operation that method supports. So let's go see. So I create this class, and then this class has a implementation of iResource Provider, and the class has a patient resource type. So in here, if you see, to read a patient resource, it creates a new patient. It creates a new patient, adds identifier, get the identifier, setup system. So URN happy MRN, and setting value, add a family which is test, add a given name which is patient 1, and get gender administrative, gender it's a female, so returns the resource. So again, if I want to search with someone, I can search using by creating a new object, patient object, and then I should get those identifiers and then do a gender and then get the single list of patients. So I can add more methods to it, and then once the resource provider is created, I have to define the server class. So in this case, Happy actually provides a server class called RESTful Server, which is specialized our Java servlet. So if we see, look at here, we do see the RESTful Server here, which we extended in here, and then we are adding those resource provider that we just created, and that's pretty much it. So these are more detailed that if how do we configure the server's identity and all. If we go through all this, it's pretty easy, and then once we're done creating the server, all we have to do is deploy the server to a container. For example, we can use Tomcat, which is freely available, or there are some proprietary ones too, like WebSphere, Glassfish, or JBoss, or WebLogic, etc. So I have to build the servlet to a WAR file and then deploy it to an application server to expose that server to call by the RESTful clients. There are also some specific behavior that we should also include in server, like paging response. The server and the history operation both will return bundles which might contain 0 or more resources. So say for example, if a search contains 80 resources, we won't be able to see all of them together. We will see only the first 20, and then which will give us a link to see the next 20 and so on. So by default, next server RESTful server will not page, but if we actually if you actually uh, return all resources immediately in a single bundle, there are two complementary parts for paging support. So we should add that, so which is called paging provider. There are two key methods for that. One is store result list, one is retrieve result list. So these are the two. And then also, if the server supports the paging provider, a further optimization is also use a bundle provider. A bundle provider simply takes place of the list and return types in your provider method. When using a bundle provider, however, the server will only request a small subset of resources as they are actually being returned. This allows server to optimize by not loading all resources into memory until they are actually needed. So this is a good thing to implement in the server to make it less resourceful. And there are some other common method parameters here also: subsetting, summary, element on parameters, automatic exception handling, generating a specific HTTP error response. So meaning that if the response fails, so it should return you either 404 or 500 error that the server is having issue, or the URL is not resource not found, or HTTP 422 unprocessable entity, something like that, returning the operation outcome for errors using the server. So your RESTful server should now support method you have declared, and here are a helpful trick. If you want to see a more human readable forms in your JSON, you should do pretty printing, which will help to to make it more readable. Now I will demonstrate the use of CRUD operation with var, and then demonstrate the use of bundle, and then how to do search for fire data. So let's start with simple read. So in this code, what I did is, first of all, I set up the fire context and all, and then for that I use the DTSU3, which is the FL7 fire DTSU3 model. And then in the first part, I wrote a method where if I pass a patient ID, I can read the patient name. So in this method, I created a patient object, and in the client, I'm calling the read method, and I added the resource as a patient class and with ID. So I'm passing the ID, which will read the patient with that particular ID, and then I'll execute this. So after executing this, my resource now has patient data to it. So from patient data, if I do get name and get the patient object and get the name as a single string, I should just get the name of the full name as a single string for this patient. So we will go to testing to verify whether it's right, correct, or wrong. And these all methods are actually given from Fire API. Let me show you. This is, I didn't have to write anything. These are all the method, like get given, get family, get name as a string, get prefix as a single string, get prefix, get suffix as a single string, get text. All these methods, get ID, get use, all these methods are actually written on the Fire API, Java Fire API, so that I don't have to write anything all over again. I don't have to reinvent the wheel. I can just use it as is. So I will put my method back. Now let's go to the second method. So in this method, what I did is I'm passing a patient name, and as you know, a multiple patient can have same name. So if multiple patient has same name, it should return me a list of IDs for those patients. So what I did in this case is I created a list, which is an array list to store the results, and in this part I created a bundle. So the bundle object is more like an array, so it can hold many results together. So that's why it is called a bundle. So I created a bundle called response, and my client is searching. So it will search with the name that will pass. So the resource that it will search is the patient resource, and the condition that I'm going to give is the patient name that matches any value with the provided name for the method. And then it should return me as a bundle class. So it should return me the result as a bundle, and then I will execute. So after executing, I actually got a response in the bundle, and now if I want to read those response, I have to run a loop. So I'm running a for loop to get the patient ID for each patient, and then adding those IDs to my result so that I can get the total, get all the IDs for those patients. So what I'm doing in here is, I'm trying to get the resource, and from there I'm getting the get ID element, and from the ID element I'm getting the ID part only. There's one more thing to it, which is if the result bundle result does not give me more than 20 patient, the result will only show me only first 20 patient results. So if I want to loop through all the patients, then I have to actually go through, check if the response has any link. So if the link contains any value, then I will actually load those next page or the rest of the values, and then I'll execute again and I'll read those values again and store in my result again. So at the end I'm just printing the total result size so that I know how many IDs I got for that patient with that name. So let me this is the simple test where I can test whether my simple read and search is working or not. So I have an expected name called Max Musterman, and then I have a test name called Parks for for my list of IDs. So let me run it. If it works, then the test will pass, and I should be seeing the number of patient IDs for that particular name. So here if you see, I see 59, which is the number of IDs that I got for the name, which is Parks. So this is an example of how we can read the data from simplifier, and then also we can do search from simple fire. Also we also showed how bundle actually works and how they store data and how can we retrieve data from the bundles. Now I'll see some other methods. This one is a little bit advanced. So this is a create method. So in this case I will actually create an observation. So I'll create an observation for the patient. So in this case I need to know the patient ID. So at the beginning what I did is I created an observation, and then from there I actually set the reference for the patient ID, because I need to know a specific patient ID. It has to be unique. Then in my observation I'm adding a code. In this case I'm adding a LONIC code, um, and then I'm passing the LONIC code display name also, and then I'm setting the quantity. So I'm setting the value, I'm setting the unit, I'm setting the value code, and then the method for the outcome, I'm actually creating the resource from the observation. I'm doing a pretty print, and then I'm executing, and it will give me actually new ID which I'm getting in here, and which confirms me that I was successfully created a new ID. So let us go ahead and then test this method. So in this method I'll choose patient as this patient ID, and then I have some linear code which is for glucose, and the value is, I have set up the value as 118, and then I'll run this test. If I successfully get an OID, that means my test actually passed. Yes, so I passed the test and it returned me a new ID. So now let's go to the update. So we have already saw read and create. Now we are at update. So update is very similar to create. We will create an observation object, and from that we will set ID, the observation ID, and then we'll set the quantity. So from the quantity we'll set value, and both value for observation and the set value, and then in the method outcome we'll pass the observation same as the way we passed for the create one. In this case it's just, we are just updating the values observation using observation ID and the passing the value and returning the getting the same ID part. So let us go and test it. So I'm passing the home phone here to this, and the patient ID is this. If you see, then if I run it, it's going to the happy fire, and then it should give me the new ID. So it ran without any issue, meaning that my test passed and the record has been updated. So now we'll go to see the delete. So in the delete, I am given a patient ID, and with that patient ID all I need to do is search that ID and then remove the patient by calling the delete client delete method. So that's pretty much it. Let me see if I can delete it. So in this case I'll go to a patient, then from the patient I'll search for a patient, and this I'll find this ID, and then I'll call here. I'll set this ID to this one and call this method to see if it is called. So it gives me an error saying that there's a conflict, unable to delete the patient because at least one resource has reference to this resource. First resource was found, so we cannot really delete this patient because there is a dependency on this patient. So this is a good example to show that sometime if we want to delete someone by accident, we cannot just do it just like that. We have to actually be careful about like how we want to delete a resource. So this conclude the demonstration part of the CRUD operation and the bundle um, uses and how do we search on using for fire data. The fire specification defines a set of data types that are used for resource element. So there are four categories of data types usually. So one is simple, the primitive data types, which is the single element with primitive values. The general purpose complex type, which are reusable cluster of elements. Metadata types, a set of types for use with metadata resources. Spatial purpose data type defined elsewhere in the specification for specific uses. This page describes the general purpose of database, so we'll just go over it. So a primitive type can have an element which has the functionality of date or time separately, and the instance which will actually capture the date time, either date or time. The base 64 binary is to store large files like images and PDFs. Boolean is for when you have a true or false element, then you can use Boolean. Integer is for integer numbers. String, you can use a string for code, ID, or markdowns. There are unsigned ints and also positive ints. And then the general purpose data types are codable concept, coding, money, backbone, element, quantity, sample data, signature, address, contact point, human name. So human name can have be reusable, it can be updatable. I can change the name, I can change the address, and so on. The age also changes by the date. So the metadata element type has contributor, contact details, related artifact, uses context, and then special purpose data type has XHTML narrative extension. And also the primitive data types are like it actually tells you in the documentation that what the data types do. So as I said, like boolean is for true false, integer is a signed int range from negative to like regular numbers, and then string is a sequence of unicode character, decimal is a rational number, URI is a uniform resource identifier reference, and so on. The stream of bytes is the basics of binary. Date time is date time, and then if we go straight, so it tells us and the value, the representation value can be either XML, JSON, or turtle. So this is XML, JSON, and then RDF is this part. So complex type has a mapping like this. If we see the structure is like this, if we look at the JSON one, so we see it has content type, language, data, URL, size, hash, title, and creation. So the creation of the time, the coding has also version, code, display, and a boolean value whether if the coding was chosen directly by user or not. So these are all for different data types that Fire uses. These are all predefined and well documented for anybody to use while developing a Fire application. The next thing we want to talk about is the extensibility. The exchange specification is based on generally agreed common requirements across the healthcare, covering many jurisdiction, domain, and different functional approaches. It is common for a specific implementation to have valid requirements that are not part of these agreed common requirements. Incorporating all the valid requirements would make this specification very cumbersome and difficult to implement. Instead, the specification expects that additional valid requirement will be implemented as extension. So if we see this example, this every element in a resource data type includes an optional extension child element that may be present any number of times. So basically, these are all dependencies, so you can use it if you want to, otherwise you can ignore it too. But then these are there for the developers to use. Like say for coding has a child system, child element called system, and then a child element called code. um, URI has a period, and the period has value period and the start date. So things like that. So these are the some example that we showed for extensibility. So fire is very extensible, and then you can always extend to these extensions to adjust your need. Then we go to the operations. So mainly we know there are four type of operations which are CRUD operations. So you read, you create, you delete, you update. And then there are some other operations like say validate a resource operation. So in this operation, you can actually validate whether the resource is valid or not. So these are external operation that is also supported by fire. So it is very convenient for the developer to use a fire application where these type of RESTful API operations are available on top of cloud operations in your hand. So you can also create a delete profile tag security level for a resource, so things like that. So you have like some of the operations are actually for multiple resources involved. So you can, if we go through all this, we can go to one of the resources. I'll go to the validate a resource operation and see how they, so this is the URI to do that. We can see, and then they tell you what to put, and this is an example of it. So in this example we are trying to create a patient, and we are trying to validate if the patient is request. So the validate purpose the patient update for this example using the parameter syntax. So we are doing that in here, and then if all the validation is valid, all the resources are valid, then only then it actually updates the resource. So this is pretty much a good example like how we can use the external operations. So in this tutorial, this is a very basic tutorial for to learn how to use fire. You can start with fire. You can do the basic CRUD operations, and by reading the all the documentation that fire has, you can actually go further and read through all the APIs. So this is just a starter for you, and now you can go dig into more detail about how you want to um, like learn and work with fire. Thank you. This concludes this tutorial.